Hi, ladies and gentlemen. Today we're going to talk about using Venn diagrams. So the first thing is this is in your textbook, and I'm just going to go through it quickly. So this is in the Venn diagrams section of the probability chapter in your textbook. Okay, so you can open that now if you'd like and follow along, but it's all here. Okay. So just some terminology and what the Venn diagram shows. The complement of a set A. So a set is basically a collection of things. So for example, a set could be all the cards that have hearts on them. A set could be all even numbers on a die. A set could be all the tests that got a level 6. Right? So it's any collection of things as a set. Okay. So the complement of a set is denoted by A prime. And what it means is it's everything that's not in A. Okay, so in the Venn diagram, if this is A complement is all the stuff outside here, right? So everything that's not in A. So for example, if A is the set of kings, A prime is the set of all the other cards that aren't kings. Okay, the intersection is what happens. So the intersection of A and B. So A and B are two sets. So let's say kings and hearts. Okay, the intersection is everything that's in both. So this would be the king of hearts. That's in both kings and hearts. So the intersection is the thing that happens in both A and in B. And in a Venn diagram, it's this little crossover area right here. Right. So that right there is the intersection. Okay. The union is it's whatever happens in A or in B. So when we're talking about kings or hearts, so the union is all the kings as well as all the hearts, as well as the king of hearts. Okay, so the union is everything that happens in either one or the other or both. Okay, so the union is everything in A as well as everything in B. Okay, so that's the union. Okay, so intersection is just the middle, union is both. Okay. So when we have union, we can use something called the addition rule. Okay, and now notice that the middle is overlapping. So it's like yesterday. Remember how we had to calculate A and then the middle and then B, right? So a good way to calculate that is you take all of A, right? Then you take all of B, and then you realize that you've added the thing in the middle twice, so you subtract it. Okay, so we'll see an example of that today. And then one piece of terminology that you need to know is what happens when sets are disjoint or mutually exclusive. Okay, so if the intersection is 0, so you see here in the Venn diagram, their intersection 0, there is no intersection. Right? The events are called disjoint, and they're also called mutually exclusive. Okay. So disjoint and mutually exclusive mean the same thing, and it means that they have no intersection. Okay, and also if you look back at this formula, A union B is A plus B minus the intersection. Well, the intersection is empty, so if two sets are mutually exclusive or disjoint, you can see that the union is just A plus B. Okay, so quick refresher: A prime means everything not in A. Intersection means everything in both A and B. Union means everything in either A or B or both. And if two sets are disjoint, it means that their intersection is empty. Okay? So using all this stuff, let's do a couple of examples. So determine using the laws of probability, the probability of drawing a card of a deck, which is a king or a club. Okay? So it's a king or a club. So what we want is the probability that our card is a king or a club. So that means union, a club. Okay? So king, union, club. Okay? So looking back at this formula, right? If it's a union, it's going to be kings plus clubs. Okay? So let's do that. So the probability that it's a king plus the probability that it's a club, and then we have to subtract off the probability that it's both. Okay, I'm going to show this in a Venn diagram in a second. Okay, so the reason why we have to do that is because when I do the probability that my card is a king, well, that's 4 out of 52, right? 4 kings out of 52 total cards. The probability that it's a club is 13 out of 52, right? So 13 clubs out of 52 cards. But if I draw the Venn diagram, here's kings, here's clubs. I've got 4 kings and I've got 13 clubs, but I've got one card that's both, right? So what that means is that there's actually one card that's both, and I counted this card twice, once in the kings and once in the clubs. So that means that I have to subtract it once. So let's annotate what's going on here. So this is 4 kings, right? This is 13 clubs, and this is the 1 king of clubs that we counted twice. Right? So we have to get rid of it once because we only want to count it once. Right? So we get our final answer, which is 4 plus 13 minus 1 is 16 out of 52, and we can reduce that to 4 out of 13. So the probability of getting either a king or a club is 4 out of 13. Okay? Alright, so a bag contains 55 pieces of paper, and they have the numbers 1 to 55 written on them. Okay, determine the probability of drawing a divisor of 36. Okay, so the first thing that we got to do is we got to figure out what the divisors of 36 are. Right, so that's our whole list. 1, 2, 3, 4, 6, 9, 12, 18, 36 are all divisors of 36. Okay, so that means that the probability of drawing a divisor of 36 is 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 55, because that's the number of choices, right? So 9 out of 55. Now I want to get the probability of drawing a divisor of 54. So that means that the probability of getting a divisor of 54 is 1, 2, 3, 4, 5, 6, 7, 8 out of 55. Right? Now the probability of drawing a divisor of 54 or 36 is going to be probability of divisor of 54 union, because it's or, divisor of 36. So this is the probability, right, using our addition rule again, divisor of 54 plus probability of divisor of 36 minus the intersection. So divisor of 54 intersect divisor of 36. Okay, so now let's put numbers to this stuff. Well, probability of divisor of 54 is 8 out of 55. Probability of divisor of 36 is 9 out of 55. And the probability of both is, well, let's highlight. So 1 is in both, 2 is in both, 3 is in both, 4 is not in both, 6 is in both, 9 is in both, 12 is not, 18 is. So the probability of something in the intersection, so I've counted all of these and I've counted all of these, but the ones that are highlighted, I've counted them twice. So I have to subtract off 1, 2, 3, 4, 5, 6 out of 55, right? Because 6 of these and 6 of these are the same. So I just want to count them once. So 8 plus 9 minus 6 is 11 out of 55, which we can reduce to 1/5. Okay? So that means that we have a 1/5 chance of drawing a divisor of 54 or 36. Okay? All right. So here is a little bit more of an abstract one. So we have the probability of A is 0.6, the probability of B is 0.4, probability of A union B is 0.8. We want to figure out the probability of the intersection. Okay? So Well, we know that there's an equation that relates A, B, union, and intersection, right? So let's write that equation down, right? We know that A union B is A plus B minus the intersection, right? So A is 0.6, B is 0.4, intersection, I don't know, so I'll call it X, and the union is 0.8, okay? And now all we do is we isolate for X by moving all this stuff to the other side. So we get a 0.8 minus 0.6 minus 0.4 is negative 0.2 is equal to negative X. So we get 0.2 is X, therefore A intersect B is 0.2. So A is 0.6, B is 0.4, the union is 0.8, and the intersection is 0.2. Okay? Now the probability of B prime. Well, we know that the total probability of everything is 100% or 1. Okay? So that means that either something's in B or it's not. There's nothing else that can happen, right? So the way to approach this one is we consider the fact that the probability that something's in a set and the probability that it's not is 1. Right? So we know that probably that something's in a set. And so, for example, if B is all the people that got 6s on a test, well, either you got a 6 or you didn't, right? I'm 100% to pick somebody that either got a 6 or didn't, right? One of those two is going to happen, right? So we know that the probability of B is 0.4, right? And then we just isolate and we get that the probability of B prime is 0.6, right? Because we take the 0.4 over and we're done. Now we want A intersect B prime. Okay, so this one we don't have a good formula for because we don't have A union B prime. But let's look at what the Venn diagram says. Okay? So if I have A here and if I have B here, okay? And I want A intersect B prime. So I want everything that's in both A and not in B. Okay, so what I'm going to do is in red, I'm going to color A. So here's A. Okay, and then in green, I'm going to do B prime. So if this is B, this is going to be B prime. Right? So now the question is, what is in the intersection of A and B prime? So that means what's in both A and B prime. Well, that's actually all of this stuff here. Right? So what that means, right, we have that A intersect B prime from the Venn diagram is actually all of A take away the intersection. Right? So here's A, here's B, this is the intersection, so this is all of A minus the intersection of A and B. Right? So all these numbers we know. That is, so A is 0.6, and the intersection is 0.2. Right? So A intersect B prime is 0.4. All right. Okay. So this example might have been a little bit complicated. Replay it if you need to. And there's your homework. All right. 511, number 1 to 12. All righty. See you guys soon.